Modern design has developed a terrible reflex. When a structural failure appears, the instinct is to bolt on a superficial patch rather than questioning the foundation underneath it. Take a traditional steel ship. By simply existing, a massive ferrous hull creates a large, moving distortion in the Earth's magnetic field. The industry standard response to this is to add degaussing coils, electromagnetic cables wrapped around the vessel to artificially cancel out the magnetic signature the hull naturally generates. Bolting on those coils after the fact is an incredibly expensive admission of failure at the material level. The alternative is to move the intervention entirely upstream to the concept phase, where a flaw can be mathematically erased before production begins. A recent Depix design study asked what a hull should actually be made of, resulting in a molded composite monocoque that uses absolutely zero ferrous metal. It relies on absolute structural purity. There is not a single plate joint or weld seam anywhere on the architecture. Deciding upstream prevents the problem from ever entering the physical timeline. The magnetic signature isn't masked, it simply never gets built. This exact philosophy scales to luxury architecture. Soyasla Marine recently put the first hull of the Dionysus 35 in the water, providing a masterclass in spatial requirements. Instead of relying on a refit yard to hack a finished boat to accommodate a wheelchair, they designed this production series to be accessible as a core platform requirement. This diagram shows how setting that requirement early structurally links multiple elements. The math simultaneously drops deck heights, widens doors, and opens up interior sightlines. Pushing those interconnected dimensions around costs practically nothing while they remain conceptual vectors on a screen. True structural accessibility is a geometry problem you solve upstream, rather than a carpentry problem you force someone to fix downstream. In automotive design, even aesthetic legacy has to be treated as a strict structural requirement. Look at the Porsche 911 GT2 RS flakbow. The historical homage is physically forged into the geometry itself, defined by newly shaped wheel arches and a broad U-shaped contour stamped across the hood. Committing to new physical hardware is incredibly expensive compared to the downstream alternative of applying flat vinyl decals over an existing surface. But three-dimensional space is unforgiving. When a human walks around an object in person, only hardware-level geometry survives that physical scrutiny. Upstream design must anticipate invisible human psychology just as rigorously as physical engineering, which brings us to Porsche's E-Shift technology. A traditional mechanical gearbox always performed two jobs. It transmitted physical torque to the wheels, and it provided the driver with a predictable, invisible rhythm. This graph contrasts those two functions. The flat, continuous line represents the effortless torque delivery of an electric motor, but that perfectly smooth power abandons the sharply pulsing, stepped wave, the mechanical rhythm humans expect. Because Porsche recognized rhythm as a strict upstream requirement, they engineered it back into the platform using virtual gear changes, sharp shift kicks, and acoustic feedback. When technology strips away a physical interaction, the designer has to deliberately architect the human experience back into the machine. Generative AI models are built to constantly drift and surprise you. Professional product design demands the exact opposite, absolute consistency. An object's complete structural identity has to be locked down with absolute certainty before it ever leaves the concept phase. The physical assembly line is the ultimate point of no return for any design concept. It marks the precise transition where infinitely flexible digital math suddenly hardens into unyielding steel, composite, and industrial tooling. Design decisions are as cheap as a pencil sketch when you establish them upstream. Once physical tooling begins, those same decisions become brutally permanent and costly to undo. You have to possess the intelligence to see every angle and every consequence of a design before the building phase even begins. Decide upstream.